Alrighty. Hello everyone, my name is Logan Bro, and this is my video for AI Assignment 1 of the Duke University AI Product Management course. For this assignment, we are trying to calculate the net hourly electrical energy output, PE in the dataset up here, of a power plant from a dataset provided to us by Duke. So to start, I took 20% out of that full data set as a test set, and then 10% out as that validation. You can see for the test set that ends up being just under 2,000, and then for that validation set, just under 1,000. I think that gives a good combination of tested and validation data. We started with just over 9,500 data points, so again, that gave us around 2,000 to 1,000 kind of as a split. I put them into 4 scatter plots, just using each load here, just using each one of the inputs as it relates to that energy output. Definitely not visually appealing here, but I think it got the job done. Basically, the thought I had was to look at which had the most direct correlation. I think unsurprisingly, at least for my brain, that was the temperature data that clearly had the clearest trend line there. And because of that, that's the value that I chose to remove as a data set for these 2 regression models that you'll see in a bit. Zoom in here. So as a note, I did use a linear regression here. That's not something I think just in general, not something I'm super versed in, but the company I work at and the company I'm doing this for, pretty strict regulations on what we're allowed to use. So Excel was kind of what we landed on, certainly from a recording standpoint. And I think that it ultimately it does a fine job of showing the importance of the relationship between all of the inputs towards electrical output, and then of course kind of why temp might be the most important one there. So I'll jump over here to the regression models. I made 2 regression models. Again, one with that full data set. We'll start here with all the data points, and then one without. Slide over here. First thing I did was pull the coefficients of each sample data set. This is again, if you've ever used the data analysis tool for Excel, I would highly recommend it. For regression 2 here, you see a very high R square, almost 9.3. I think again that means that there's a high correlation between all those inputs and the output that we're given. Scatter plots here just to kind of show that I think the correlation there is seen in scatter plots as well. Regression 1 is then without temperature included. As you can see, it's quite a ways off, which would lead me to believe that we should not be removing temperature as an input for one. But a pretty unsurprising that you see almost a 10 point, 11 point drop there. So there we go. After creating those regressions and knowing the coefficients, I calculated the mean square error and the mean square percentage. You'll see this here. I should have broken these out a little clearer. I think to my surprise, these were fairly similar. You can see the mean absolute error here, only off by really less than 1%, which was surprising to me given that the R squared was so different. I did kind of go through this data a couple times just to make sure I wasn't missing anything there. Mean squared error is obviously I think a few more points off, almost 30, 36 rather, points off there. So you see there's some variation, but I would have expected to see that absolute error percentage change. And then for the test set here, same process. I will call out that the mean squared error is pretty similar here. If you go back to this validation set, that's a less than a point change there. So that stayed the same, but the mean absolute error percent was down to 1%, which again that was surprising to me. So to answer some of these questions, let me go back to those. This is part of the again Duke assignment questions. I think we had 4 or 5 of them. So for the program, for the problem described in the project topic section above, determine what type of machine learning approach is needed and select an appropriate output metric to evaluate performance. So again, a lot of this is to do with only being able to use Excel, but this is something that I think I could use in the future as well. But I chose the regression model. Again, we're looking at relationships between one or more numerical values, and then use the coefficient of determination and mean absolute error percentage there. Determine which possible features we want to use in the model and identify the different algorithms we might consider. So I chose again to use all of those data points for the first regression, and then to remove temperature for the second regression. I thought that was going to have the most variation just in my simple understanding of power plants. Split your data to create a test set to evaluate the performance of your final model, and then using your training set to determine a validation strategy. So again, I removed 20% of the data as a test set. I was able to do that just by removing every fifth line of data via a simple script. And for the training set, I took 10% as the validation uh, of the, sorry, I took from the training set, goodness, I took 10% of the validation set, which ended up being those 956 points. I can share my screen here and show you that. Yeah, use your validation approach to compare at least 2 different models. Yeah, again, chose 2 different algorithms here, two different regressions, one being temperature removed from electrical output, and then the other being all inputs as it relates to electrical output. Last question is evaluate the performance of your final model using your output metric you defined earlier. So using the coefficient of determination and mean absolute error. I guess personally, I mean, if 1% is mean absolute error percentage, that's pretty good. That's something that I think is easily explainable to anyone that's looking at this data, that this is a very correlates well. I just kind of as a takeaway, I think there's probably better programs to use that you could do this much quicker. This was kind of monotonous work. Even again, I'm not a whiz on algorithms by any means, but it was something that I think, given some of the tools, obviously this is an AI course, something that I think we'll be able to do better in the future, certainly with some updated tools. So thank you, and I will stop the recording.